Alrighty. Okie dokie. So this is what I have planned tonight. So let's get into it. Throw on some Pomodoro real quick. No. Yep, that's my baby. And we'll throw on the beats. So I found this cool tape. I was interested in learning some C++. So let's go ahead and do this. There's a bit of an introduction here. I feel like I'd rather straight into syntax. Maybe I can do those other things when I'm eating lunch or something. Let's go ahead and get straight into this.
Welcome to the first coding lesson, an introduction to the C++ language. The goal of this lesson is to get you up and running with the basics of C++, including how to compile and run a simple C++ program, and how to write code with correct C++ language syntax. In this lesson, you'll see the following concepts. To get started, you will write and run your first C++ program, and you'll also learn how to send output to the console. Then you'll learn about variables and containers, including different variable types, vectors, using the auto keyword, and then we'll move to functions and control structures. So you'll learn about for loops, how to write your own C++ functions. You'll learn about if statements and while loops. And then last, we'll learn about data input, where you will read data from a file and parse data and process strings. Oh, and there's one more thing, which is to define your own types with enums.
Okay.
By the end of this lesson, you'll be able to read a text file representing a maze into your program, and you'll be able to store the maze data. You'll also be able to output a basic map of the maze with nice formatting and ASCII characters to represent obstacles.
All right, then. Let me see if I have the repo set up so I can flex a little bit. Yeah, so I wanted to do some other courses, but thinking about, I'll leave these here. That's fine. But I'm thinking about doing this C++. I think it would be awesome. I really want to commit myself to it. Let's go ahead and do that. Yeah, I was thinking about doing a bunch of them at the same time, but we'll just stay with this one. So let's create a repo, track our progress here. All this Fastly readme.
Welcome to the first coding lesson, an introduction to the C++ language.
So let's do first one. little bit of C++, but I want to do this to just or is that C? I don't think it's see how long the rest is though. Into C out. Code. Let's see how long this is. Oh, I got that right. Using them. Oh my gosh. Perfect. Like GCC. Why not? Oh my goodness, look at that. So is this our machine code executable that you're talking about? Well, I know people has these executables, so I don't want to just put them on the same folder just for help. Let's see what this workspace was even holding. See, here, I didn't do that. I did not compile. Is that what I said? Delete this junk. In there. What if here what? So what was it? Thing is, I don't even think I have G installed. Is that something? Let's see what happens. With plus. So we had main, we had solution. This is the first time we wrote the compile language. Might be wondering why one might use what are its advantages and disadvantages. It's a good question. I always ask that. So, is it right to say that since it's compiled, you have your executable ready and it could be used on any OS? I don't know. I was thinking about this idea from Java where the JVM, I think it's called, whenever you run your Java code, I think it creates an executable with the JVM or something that can work on all operating systems. JDK. So like let's see. Alright, let's just see how this works. Compiled and scripted languages are specific. Teach me.
Well, if you want to build software that is stable and as close to error-free as you can get it, the compiler is your best friend. Because the compiler is a program that checks that you have followed your own rules and the language's rules, even when that's very tedious and difficult. With a dynamically checked language, you have to rely on having completely tested your program. And that never happens. The last bug is an old joke. I mean, you never get it. But if you have a systematic set of rules, which is what a language is, then you can have a machine check it for you. It doesn't bore, and it's much faster. And that comes together with the idea of the abstraction mechanism in C++. If everything you do is sort of hardware level, pointers, arrays, built-in types like integers and floating point, it's limited what a compiler can do for you except for generating code. If you abstract so that you have hash tables and complex numbers and n-dimensional matrices or whatever graphical shapes with manipulation of the graphics and things like that, then the compiler can start helping you to avoid stupid things. In a runtime checked language, a dynamically checked language, you have an I/O stream, a stream that goes out, an image stream, and you try to rotate it with an operation that is meant to rotate the shapes on your screen. In a dynamically typed language...
Oh, what the hell is that? So there's two types of programming language, dynamic and typed. Okay. And dynamically typed languages are where variables are checked at runtime and compile time. What's the difference between runtime and compile time? Runtime and compile time. Um, see. See. Then it compiles. Python. Trying to get out this. Trying to get out to do. I feel like trying to understand these details are helpful if you're thinking about a solution to a problem that can be coded in Python or in C++. You know, I think thinking about this stuff is helpful for you to determine that answer. Anyway, so compile time is when the source code is translated to the machine. Yeah, that's true. Runtime is when that code is being executed. Okay. So runtime is after compile. Right? Alright, so actively languages script type and type dynamically typed are when variables runtime rather than positive. And what are examples? JavaScript, Python, and Ruby. So C is not one. And allows for faster coding. So I think the power of type languages are that during compile time, I think the power of type languages are that when, so I guess errors are caught, you're going to discover errors during compilation and not after, right? Okay. How? Let's read things that this guy said.
Well, if you want to build software that is stable and as close to error-free as you can get it,
Okay.
the compiler is your best friend.
Okay.
Because the compiler is a program that checks that you have followed your own rules and the language's rules,
Type language.
even when that's very tedious and difficult.
Okay.
With a dynamically checked language,
on the other hand.
you have to rely on having completely tested your program. And that never happens. The last bug is an old joke. I mean, you never get it. But if you have a systematic set of rules, which is what a language is, then you can have a machine check it for you. It doesn't bore, and it's much faster. And that comes together with the idea of the abstraction mechanisms in C++. If everything you do is sort of hardware level, pointers, arrays, built-in types like integers and floating point, it's limited what a compiler can do for you except for generating code. If you abstract so that you have hash tables and complex numbers and n-dimensional matrices or whatever graphical shapes with manipulation of the graphics and things like that, then the compiler can start helping you to avoid stupid things. In a runtime checked language, a dynamically checked language, you have an I/O stream, a stream that goes out, an image stream, and you try to rotate it with an operation that is meant to rotate the shapes on your screen. In a dynamically typed language, it will find the problem and give you an error and send you over into the debugger. In a compiled language, it will say this program will never run. You have an error. And this is important because a lot of the application I'm thinking a lot about are going to run places where there won't be a programmer. So sending something into an error handler or a debugger is not going to help at all. There won't be a programmer in the house. I mean, if that camera decided that the program was wrong and it's done something bad, the only thing it could do is to stop. You don't want a telephone switch to stop just because there's not a programmer in the house, or the engine of your plane or something like that. No. So the first reason the compiler is your best friend is that it catches errors systematically and early. This, by the way, means that you have to think a little bit harder when you write the code, because you really have to get it correct. You can't just be sloppy and it works most of the time. That's not what a compiled language does. And the second thing is it generates much better code. So something like C++, it's not uncommon to find it runs 10 or 50 times faster than alternatives. But the first level of defense in the compiler is simply to get the code correct.
Okay. So, I guess the main idea of what he just said here is that type languages are because there are errors in the compile. It's not compiled. And that helps you catch more errors. The example, I didn't really understand, but I think that's fine. Let's keep moving forward. Maybe if we're walking, ask someone. Alright, let's keep moving. Advantages of a dynamic placement language. Alright, sure. What are the advantages of a dynamic placement language?
Well, the advantage of a dynamic language is exactly the mirror image of the advantage of a compiled language. You can get to run quickly, and you can run all kinds of things, even if they are completely correct, if they're not completely correct. So say if you're doing a series of experiments with some data, generate some data, display it, generate data, change the algorithm, run it with a small data set. It doesn't matter if it's 10 times or 50 times slower, but it is really nice that you don't have to go through the compile step and wait 30 seconds or half an hour to get the optimal code completely checked. So if you're doing sort of interactive experimental stuff, a dynamically checked language, JavaScript or Python or something like that, has an obvious and simple advantage. On the other hand, implement something like JavaScript. You want to write a JavaScript engine? What do you write it in? C++, of course. So you don't actually ever use a system that only uses one language. That for big systems, that time went 30 or 40 years ago. You use combinations of languages, and professionals know more than one language so they can pick the right one for the task. 10 is getting hard, but as you get older, you pick them up anyway. But start out with 3 to 5, and then you may feel that you can do something.
Twitter. Sign up. I think I've logged in. Stuff. What's this? Damn it. Okay, that's nice. STD. What does that mean? I was thinking of okay. That's again. Search list. I'm trying to look for a diagram. Okay, what if it contains the declarations for the input and output space so we can stuff. Yep. Nice. And that's it, right? Cool. Send output to the console. Yep. There. Store data. And the next few store data and basic variables, prototypes, and vector containers. Tell me all about it.
You say that a language is strongly typed if an object can only be used according to its definition.
So Python is not strongly typed because, what do you say? Because an object can be using freaking whatever, not even
Its definition. And by that definition, C++ is mostly strongly statically typed. However, to deal with hardware, sometimes you have to weaken the type checking because a lot of hardware is just a bag of bits. You want to allocate memory, it's just memory till you say what type it is. And in this sort of in-between time where you grab some memory, say from the operating system or straight from the hardware, until you make it of a given type, well, it's a bag of bits, and we wouldn't call that strongly typed. Similarly, there are ways of suppressing the type checking in C++. For instance, you have an integer, and you want to make it into a pointer to a device register.
All right, teach me. What are some types in C, my friend? All right, so we got a couple of types here. Strings, floats, ints. I got include string. There you go. Nice. Gotcha. Let's go ahead and make something beautiful here. There it goes. Go ahead and do that is a preprocessor. this beautiful code. What is a vector? That's a good question. I guess it's just no, that's what C is. In C. I don't think a vector is just a pointer to.
The core of most applications are some data types, and you start with the really simple one. The default one in C++ is the vector. It's simply a linear sequence of contiguously allocated memory. That's the most useful data structure there is. There are linked lists, which people overuse.
I was thinking. What?
The core of most applications are some data types, and you start with the really simple one. The default one in C++ is the vector.
Okay.
It's simply a linear sequence of contiguously allocated memory. That's the most useful data structure there is. There are linked lists, which people overuse. Sometimes they're necessary. Then you have the hash tables and the maps for collections of data that's kept sorted so that lookup is much faster than lookup in other data structures.
I'm not gonna lie. My data structures is buns. It is so buns. Fuck. Oh man. The previous concept we learned about some of the primitive C++ offers, including strings and ints. And you learned how to store these types in your program. Check that out. 1D vector. That's cool. Oh, look at that. Nice. Look at that. Why is it defined like that? Let's get a feel for the first project. What do you want to think? See what's going on. Build an OpenStreetMap.
Welcome to the final project. In this project, you will use everything that you've learned up to now, including writing code in multiple files, pointers, references, and a little bit of OOP. You will build a route planner that plots a path between 2 points on a map. This may sound similar to the project you completed in the first lessons of this course. This time, however, instead of using a simple grid to represent the map, you'll be working with real map data from the OpenStreetMap project to generate a path on a real map. This is similar to other mapping applications you have used, like Google Maps or Apple Maps. To render the map data, the project code will be using a 2D rendering library called IO2D.
Put that here.
Much of the code for parsing OpenStreetMap data and rendering the results comes from the library example in the IO2D code repository. To get you started on the project, we'll provide you with a slightly modified version of this example code that has all the classes and method stubs that you'll need to complete the project. We'll fill in the methods that are required to make the code perform route planning. The route planner will use the A-star algorithm, just as you've seen before, so the code structure should seem familiar to you from the first lessons of this course. However, because of the complexity of the OpenStreetMap data and the IO2D library, the project code will have object-oriented structure. In the rest of this lesson, we'll carefully review the structure of the project code that we provide, and we'll clarify what is required to complete the project. In particular, we'll have an overview of the OpenStreetMap project, including the data format of the OpenStreetMap data and the element types that you'll see in that data. Then, you'll see instructions for building and running the project and testing your code. Next, you'll see a project code overview that'll include a class diagram so you can have an understanding of the high-level structure of the code. Then, you'll look at the project starter repository structure, including all of the files and folders in that project repository, and we'll look at the source directory in that repository in particular. We'll have some code walkthroughs so that you understand all of the code that you're starting with. Next, there will be some steps that you'll need to follow to complete the project. And in the last part of this lesson, there will be a project submission instructions and a workspace. This is an extremely exciting project, and we can't wait to see your submissions.
Okay, that's pretty cool. It's really neat. Okay, how do you comment? Just slash, right?
Comments should be used to say things that you cannot do well in code. Obviously, the code tells you how something is done. It doesn't tell you what at a high level is being done or why it's being done. So you have some code, and it does a sort. You would like a comment that says this is supposed to be a shell sort, and now you can look it up in the book and see and check the code and see if it really does a shell sort. But without that comment, you don't really know what the code is supposed to do. So for things that you can't say well in code, if there's a complicated piece of code, explain what it's supposed to do.
Okay. Cool. What the heck is a model? I didn't know that. Whoa. I wish I could. A search algorithm, search algorithm in a grid or board to search through. We'll be working with this board that has main. We'll start by starting the hard coded board, the main function. Let's go ahead and do board. Board.c++. Include name. Using namespace and any. What do you want, buddy? Their variable board. I can do that. Back to mouse. This. Very, 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 very nice. You want me to put that? I'm pretty sure it's this, right? Okay, nice. Loops and functions. Let's see how to loop through these chunks. Let me know how to do that. Cut the crap. Yep. Just other. Look at that, we got A not size.
Let's try to print an
What?
element of B.
How is this
We'll
happening?
start with the element at the 0th row, 1. So third.
That's actually crazy. What the hell? How the frick did you do that? Print the length of the vector. Write that down. I think that's ready. Should find the size of the inner vector. You would just do b b0 dot sign.
You know what? If I
Just too smart. Just too smart. Nice refresher filling. What is here? Just as in other languages you've worked with, C++ has for loop and while loops. Alright, let's check it out. I think the for loops are pretty Two, three. Post means after thread. We know that using English. This is a range rate. Nice. Try and write a double range based for loop that prints all entries. I'll be back. See what time it is right now. I ordered from Wendy's once. They're like cheeseburgers with Jones. Actually, I can see it. Okay. Taco Bell. I ate it. harmless chocolate. All should probably finish failure. We'll order something. We'll do one more session real quick. See what we got going on. Might even be done with this right here. Alright, let's get back to it. Let's start. I like. All right. Back to it. Okay. So. This is easy. 4 vector int whatever. 4 int whatever that variable is.
I'm going to use all.
Oh my gosh, they put auto. That's one. Anyway, let's go to the next one. Let's see what else we got here. Last thing you'll need in order to do this is override a function. That's true. How the heck do we do that? Yep. Do I have to do it outside of main? Yes, it is outside. Now that you see how to define, try it yourself in the cell below. Complicated function. Vector int as a argument. That makes sense. Int vector. 0 for just a number or int. No, it wouldn't be because you can scale for int. Do B plus, so it's not even in C++. It's plus E plus.
There and
What the heck did you just write here? Shoot. What the flip is going on here? Does that just not work? It doesn't make a copy. Vector int equals that should give us 3, 6, 10. Let's use int vectors. That should give us so you're doing a whole bunch of stuff here. Let's hear what you gotta say.
int as its argument. That vector will be, we'll call that v. We could call it whatever we want. And we will start by declaring a local variable sum and initializing it to 0. And at the end, we'll return the sum. And in the middle, we'll use what's called a range for loop. And we'll say for every int I that's an element of v, add I to the sum and return the sum. And if we compile and execute that, we get 6, which is the correct answer. Slightly more kind of correct, or maybe a better practice way to do that would be to take the vector in as a reference.
Okay, so what does this mean again? That means you have to give it the pointer. I'm not sure of the syntax, but if this is the case, then you're giving it a pointer. And then once you're in the function here, this will look at that address, right?
Which we'll learn about later, but that means that instead of copying this vector from main, we actually pass the vector from main directly into addition function. Otherwise, what you actually get here is a copy. For our purposes, it doesn't really matter whether we get a copy or the original here, but in general, it's better to get the original unless you explicitly need a copy because of the time it sometimes takes to make copies of things. And actually, the same thing here, we might want to reference to I instead of copying. We tell them if I would just take the
reference to I.
The raw integer itself. If we compile and execute that, the answer is 6. Let's clear our terminal. Another thing we might want to do, particularly for working with references, is to declare that vector to be a const. And we also would want to do that in here with the integer. That way, you're essentially promising that you're going to keep this vector constant, and you're going to keep this integer constant. You're not going to change it. You're only going to read it. And the compiler will enforce that by throwing an error if you try and change it. So it's a little bit of a safeguard. If we
Sure. Here. Variables can be cost.
Compile and execute that. We get the correct answer, which is 6. If we want to look at a different way to do this, we could iterate over the elements of V using an index. This is the way that I did things when I was first learning to code in C way back when. So we would say for I equals 0, I less than vector.size plus I. And then we have to change here. If you guess what the change might be, you might want to pause here and fiddle with the code and compile and run it and see what happens and see if you can get the code to actually.
A lot of nuanced details here.
work correctly. So I'll stop for a sec, and you can pause this recording and come back when you're ready. Okay, are you ready? So the change here is that we now need to take the index of V and not the ith index of V and not just I itself, because I is now just counting up from 0 to the number of elements in V. But if we take the index, get 6 again, which is the right answer. Another thing you could do is to use what are called iterators, something else you'll learn a little bit more about later. You could say, we're going to start with, it's not an integer, but an iterator that is the beginning of I, and as long as the iterator doesn't reach the end of I, you can keep adding the iterator, and you can get the value of the iterator by dereferencing it. And if we compile and execute that, we still get 6. So that's another way to do things. A final way you might do things is to include the numeric library, numeric. And we can do all of this actually in one line by using the accumulate function. So I'll stop here for those of you who are adventurous. I'll pause. You should pause this video and go look up how to use the accumulate function, and then try it out for yourself, and then hit play when you're ready and see how I do this.
All right. Bet. Love to look at some documentation. C++ accumulate. No ChatGPT. Let's go ahead and look at documentation. Which one is it? Maybe this one. Accumulate. All right. Let's see which one has more. I like this one. Accumulate. Returns results. So, it's kind of scary, all this stuff. Returns the result of accumulating all the values in a range. All right. Let's see. So we got our numbers. Using default accumulate, using function minus, using custom function. So we can just accumulate with numbers and numbers plus 3. Interesting. And so, alright, I don't like this documentation. It's stupid. Alright, it's stupid. I guess I'm stupid, but I think it's more simpler here. Pair of iterators defining the range of the elements, the initial value of the accumulator. For example, here. So the initial value is 1. Oh, and you can even add a function to it. That's interesting. And you can add a binary operation. Binary operation function. Interesting. Alright, but we're not going to delve too into that.
Okay, are you ready? Here we go. So we can return standard accumulate, and we can start with v dot end, and accumulate from 0. And if we compile and execute the function, we'll get the correct answer, which is 6. And in fact, because we're doing this all in one line here, we don't even really need this addition function anymore. What we could do is just paste this one line without the semicolon into the cout function. We could delete all of this and just run it from within main. If we do that, we still get 6, which is the right answer. So lots of different ways that you could tackle this problem, and they all work.
Thank you. Return void return type. Ooh, it's cold in here. Next time. Sometimes a function doesn't need to return anything. Alright? So for example, a function might simply modify an object that is passed into it, or it might I'm not going to do that. I know what it is. Alright, let's see what we next. Alright, let's print the board. Print the board sorting program. Print it out. So you can display the results of your project. As exercise, you will add a print board and obtain the total number of time. Done. Print it out like this. Let's try. Wait. Oh man, this music is kind of.
What you want, I can't stand it. I don't need another, but I'll take it. I'm in Hollywood with the fakers, but I'm smiling good cause they paying. But I'm smiling good cause they paying. Rockstar life might just make it. I don't trust no one, I'm the only one like me. I can't pop just one, that little one just for anxiety. I don't know the rules, I don't want them dudes around me. Nigga, I'm the truth, yo, got the scoop on me. Tryna get the scoop, dope all on my spoon, honey. I dropped out of school, I don't think them rules for me. I dropped out of school, I don't think them rules for me. Do you want a demon or a rude boy? I can make it look like suicide. I don't wanna leave, it's you or I. I don't wanna leave, so it's you to die. Maybe this the life I've chosen. Maybe this the life I've chosen. Maybe this the life I've chosen. Maybe this the life I've
Yeah,
chosen.
and this language. Yeah, okay. And then that line could be here. Okay. Yeah.
This city dangerous, I won't go on a date with the hoe. This city dangerous, I won't go on a date with the hoe. Like what we making it, this all about my cake. With the hoe, I wouldn't have it any other way. Get it, girl, no finesse with them suburban hoes. Want city girls in the low and staring at the lake. Don't run a road, let me demonstrate and execute. You hear me, girl, on the E-way, I go vroom, vroom. Hear me, girl, catching feelings for a rap, nigga. City girl, but ain't no telling, though she might just put a check. Get my face crap in the venue and they didn't even check. Papa waste you in your feelings, not your bag. You in debt with me, babe, that shit ain't hurt me when it happened. I was stuck with
Yeah, we did it. Next. Now that you're able to print the board, you can make a program more flexible by reading the board from a file. You run a program with different board files to see the results. Alright, so let's talk about if and while. Conditionals, if that's what you want to call them. Yeah, pretty simple stuff. Right there. Pretty simple. No thanks. Alright, next. Now, alright, let's check this out. Let's try a new folder. So reading files. Reading files. Let's see this plus. Alright, creating an input stream object. If stream object handle to handle input file stream. To do this, you'll need to include a header file that provides this file stream classes fstream. std extreme my file path. All right. A bit nervous. Whoa. Got freaking everything here. 7 years ago. Holy schmoly. Where the heck even were we, dude? Fuck. I think we were here. No, we weren't. We were at files. Edit files, reading from file. So we're here. And files 1.board. What the hell is a dot board? Oh, it's let me download that. Don't. What the heck is a dot board, buddy? Okay. All right, so we can use this object here. Let's see what's going on here. Let's write this first. Include IOStream. Include. What do I have to do? History. Is that what it told me to do? We'll see. Using namespace SD int main times 0. And then yeah, this look real. F-string, that's what it's called. F-string. And then we declare this thing, this if string thingy, and then we can open it. The open path. Okay, so first let's declare it. If stream file, right? If stream my file. And then we could do my file dot open. Let's give it a path. Been created successfully. If the stream were to initialize successfully, then the if stream. All right. I'm done. I was in red. Right, now it's pretty good. Get mine. How low do you want to get? Looks like we're about to talk. that. But live, maybe I'll go back on when I'm applying for internships later. But I'll see. Thank you.